Now that we've seen what tensors are, we can start playing around with them a bit to get a sense of what they are and how they work. So we're going to use tensors now in numpy because it's a bit easier to work with than TensorFlow. So let's define vector x. So we just draw from a normal distribution. So the syntax is a bit different because we're not using TensorFlow now, but numpy. So we start here with np, not with tf as we did before. So I'm going to draw from a normal distribution with mean 0, standard deviation 1. And I specify the size variable, so I'm going to draw 100 values. So x is going to be a vector with 100 values. So let's look at the shape. So indeed, the shape of x is that it contains 100 values. So that's as a vector. Now we can look at what the dimensions are of x as a tensor, and it has dimension 1. Yeah, because in a sense I only have one column and I have 100 rows, so I have dimension 1. So I can play around with this, so I can now define a new vector which I call x2, which is based on x, but we're going to reshape it. And we're going to reshape it in the format of 20 rows and 5 columns. So then again we can look at what the shape of x2 is. And that shape correctly points to the fact that we have 20 rows and 5 columns in x2. So if we now ask for the number of dimensions of the tensor x2, we get 2 dimensions. Yeah, so we have rows and columns, so we have 2 dimensions at x2. So if you wonder what x2 looks like, we can for instance look at the first row, index 0, and I'm interested in all the columns. And when I run this code, I can see what the first row actually looks like. Yes, so indeed, this is a row which has 1, 2, 3, 4, and 5 columns. Yeah, so feel free to also run x2, but it gives a lot of output and it's not very easy to look at, so I won't do it here. But with the syntax, you can also look at the third row, and then I want to know what is in the second column, so you can run this as well. And then you get a number which is at that point in the matrix, because x2 is actually a matrix with 2 dimensions, rows and columns. So now we can increase the number of dimensions, so I can say, let's call a new vector x4. I'm going to reshape x with 2, 2, 5 and 5, so then we get x4 shape. So this is no longer a matrix. This thing has 4 dimensions. We can check whether that's indeed the case, so we can do x4 number of dimensions, and we see that indeed has 4 dimensions, so it has 2, let's say, rows, then 2 columns, then 5 and then 5. So one way to think about this is as a 5 by 5 matrix. I have 2 of those, so I have 2 5 by 5 matrices. So I have 2 columns with 5 by 5 matrices, and then I have 2 rows as well. Yeah, so there's one way to visualize this is a matrix of 5 by 5 matrices. But the easiest way is just to think about it in a sort of abstract way as a tensor that actually has 4 dimensions. So now we can do one final step to illustrate another command in numpy. So I'm going to make this a 5-dimensional array. So the way I'm going to do that is I'm going to call x4, which is 4-dimensional. And then I specify that I want to have all the entries in the first dimension, all the entries in the second dimension, in the third and in the fourth, and on top of that I'm going to add a new axis. Yeah, so this is the numpy command new axis, and then I can ask what the shape of this thing is, and then I get something which is 2 by 2 by 5 by 5 by 1. Yeah, so if I now ask for the number of dimensions of x5, it actually has 5 dimensions. So it's a sort of 5-dimensional matrix. Yeah, so as a tensor, it has 5 dimensions, and it includes 100 elements. So you might wonder what the point is of adding this extra dimension, which has, is just 1. And the point of doing that is the next topic, which is broadcasting. So for broadcasting, it is sometimes useful that you can add dimensions to a tensor, even if that dimension is simply equal to 1.